Hello, everyone, and welcome back. We're talking about space, and today, specifically, we are talking about technologies in space. So I said it kind of sarcastically in the last lesson about how like you wouldn't be able to just jump off of the Earth, but when we go to space, that's essentially what we're trying to do. And so, if you were really, really good at jumping, you could theoretically jump off of the Earth. But nobody has ever been even close to that. Takes a lot of speed to break away from Earth's gravity. You got to get your trajection angle just right. So we figured out these kinds of things. We were able to figure out how fast we had to go, but actually figuring out how to do that proved to be a little bit more challenging. We eventually figured out rockets. And so to break free, you have to be going 28,000 kilometers an hour. In order to do that, you need a ton of fuel to release energy all at once to give you that much speed. Because speed is just a kind of energy. It's kinetic energy. And so if you take the energy that's in all of your fuel and convert it into speed energy, well then yeah, you can achieve a really, really high speed, but you have to be able to control it. So we use rockets, and the technology really hasn't changed since 400 BC. Take a second to think about that one. What do I mean when I say rockets in 400 BC? Because I don't mean that like Archimedes, who was over there thinking that Earth was center of the universe, was flying off into space. Okay, here's what I mean. There was this guy called Archytas, also a Greek dude, also probably not still alive, who figured out that if you heat water, it will evaporate, and if you do that quickly, creates force. Makes sense, the water's expanding, that has to go somewhere. So he said if you could control this, then you could use that force to push something in a direction. And so what he did is he created this model pigeon and basically put a fire underneath. There would have been water inside here. And then that heated up the water, which created steam. And as the steam pushed out the back, the pigeon went forwards. Same thing with Chinese arrows. These are essentially rockets. They're long aerodynamic things that you're trying to shoot at a great speed so that they can go a long ways and they can kill people in the military or whatever you're using them for. And if they put flights on the back, and if they had their explosion at the right point, and if they controlled all of those things so that they could control what's essentially a rocket, they were able to get their arrows to fly. Except it seems kind of backwards. Like you would think, going back to my last slide, you would think that if you want the arrow to fly that you should create an explosion that goes in that direction. But it's actually backwards from that. It's actually that you have something containing it, and if you want your arrow to go up and to the left like that, you actually have to send a force the opposite direction. The reason why is because of this guy named Isaac Newton, who came up with this rule that for every action, there is an equal reaction that is in the opposite direction. Equal meaning that if I push, or if there's an explosion that makes 20 units of force, you're going to get 20 units of force going the other way. You're not magically going to have 400. So that is Newton's third law. So it says 3 basic parts. You have structural mechanical. This is like your actual rocket itself. The fuel, this is the part that holds all of your energy that you're going to turn into kinetic energy so you can actually move. And then the payload, that's your people who are going there, the things that they need so that they can actually survive. Because we're not just sending rockets into space just for fun. We have an actual purpose for it, and that's what the people are there for. So, if we think we want to go to the moon, well, the moon is the closest sort of, it's not a planet, but it's like that body that we can actually go onto. Because it orbits a planet, it's a moon. Moon is the closest thing we can actually get to. If we want to get to Neptune, it says we're 9 years away, going as fast as we possibly can the entire time. And then that doesn't even include the fact that we're going to run out of fuel. So we've come up with 2 solutions. First one is ion drives. And now what this does is it basically takes, remember the noble gases from chemistry? Xenon is one of those. So that means that it doesn't react. So it's not a chemical reaction that we're using with the xenon gas. What we're doing is we are running an electric charge through it, and then because this is a noble gas, doesn't react, that electric charge doesn't do the same thing that it normally would. Essentially, we run charge in one way. When it comes out the other side, that's like that thrust. So we've got, that's like our explosion, which propels this thing the opposite direction an equal amount. Problem is, this is a very weak thrust. So it's not the strongest, but it is significantly more efficient than the other kinds of rockets. So if you think like your car to get from Calgary to Edmonton probably uses about 30 liters of fuel to go 300 kilometers. This xenon gas in an ion drive can go 19,000 kilometers on 1 liter. So that is a much more realistic expectation for how far our fuel can take us in terms of exploring the solar system. Next thing we're looking at are solar sails. So again, we can't carry huge masses of jet fuel on with us. What if we just didn't carry any fuel at all? Solar sails, kind of like how solar panels collect sunlight, harvest the energy, turn it into electricity. Solar sails collect sunlight, but rather than turning it into electricity, they use it almost like wind. So it's like a sailboat has wind hit it and that pushes the boat. A solar sail has sunlight, which is photons. It's like a particle. Though the photons hit the sail and they push it the same way that wind would push a sailboat. So we've got different spacecraft. We're trying to be like forward thinking so that we can be sustainable with this stuff. So we're talking about like reusable shuttles. We're talking about things that aren't just going to end up as space junk later on, that kind of stuff. Okay, probes. So it would have been a few years ago now that they were able to land a probe onto a comet, which was a pretty big deal. You would never be able to do that with a spaceship or a shuttle or a rocket ship or anything and get actual people onto that comet. So what they do is we use probes, and those have sensors on them, they have cameras, they transmit it all back to us, and then we can see what's there as if we were actually there, even though we, like humans, never physically went to that place.